Thank you for joining this lesson. We are going to do mathematics paper 2, and we are going to look at the Maranda mock, which was done in the year 2021. Therefore, we're going to look at a statistics question, which is in number 9 of this paper. Therefore, the question number 9 is here telling us that the life expectancy in hours of 40 bulls are shown in the table below. Therefore, we have a table here of expectancy in hours and the frequency f. Calculate the quartile deviation of the life expectancy. Remember to subscribe to this channel and to also share the link with your friends. I'm going to first of all start by calculating what we call the cumulative frequency. The cumulative frequency, CF, whereby we will start with 3, then we add 10 to 13, we add 12 to 25, and we add 9 to 25 to give us 34. 10 plus 4, we get 38. And finally, 40. So for us to determine what we call quartile deviation, we first of all have to know that quartile deviation is another name of semi-interquartile range. So we are calculating semi-interquartile range, which is the half of interquartile range. Therefore, what we call the semi-interquartile range, or rather quartile deviation, will be given by Q3 minus Q1 out of 2. So when data is grouped into 4 equal parts or into 2 parts, we have the median, which is the divider of any given data in 2 parts, and median is called Q2. So we should know that Q2 is median. Then now, after median, which is Q2, we have what we call Q1, which is the median of the lower set of data, and Q3, the median of the upper set of data. Therefore now, because we know the formula of getting median, then now we are going to get Q1, and Q1 is going to be given by the lower class boundary plus a quarter of the total data, which is n, then minus cumulative frequency just before the class which is carrying Q1, and we divide all this by frequency of the same class, then multiplied by the class length, which is abbreviated W. Therefore, in such a case, we can now move on to substitute the formula. We are going to first of all get what we call the Q1 class by taking a quarter of the total data. A quarter of 40 is 10. Therefore now, in the cumulative frequency, which class accommodates 10? In the first class, there is no 10 bulls, but now by the time we are reaching the second class, according to the cumulative frequency, then we can have the 10th bull accommodated here. Therefore, this becomes our Q1 class because it contains a quarter of the total frequency, which is 10. Therefore now, the lower class boundary of this class is going to be 94.5. So 94.5. Then we add a quarter of the data, which is 10, minus cumulative frequency just before this class. So cumulative frequency of the class is 13, but just before the class, we got 3. Then 3 we divide with frequency of the class, which is 10. Then we multiply by what we call the class length, which is going to be 5 for this case. Therefore, Q1, when we multiply here, 10 minus 3, then we divide by 10, and we multiply by 5, so that we may add 94.5. This will give us exactly 98. 98. On the other side, we get to what we call Q3. So for us to calculate Q3, we need to get the lower class boundary, and we add 3/4 of the total frequency minus cumulative frequency just before the class having Q3, and we divide this one with the frequency of the Q3 class multiplied by the class length. Therefore, 3/4 of 40, 3/4 of 40 is 30. So, which class accommodates 30 according to the cumulative frequencies? Therefore, we don't have 30 here, we don't have 30, we don't have 30, but in this class we have a cumulative frequency of 34, which means 30 is contained in this class, and the lower class boundary is going to be 104.5. So 104.5, and we add 3/4 of the total frequency, which is now 30, it's already calculated, minus cumulative frequency just before this class. So the cumulative frequency before is 25, and we divide with frequency of that class, which is 9, and this one will be multiplied by a class width of 5. A class width of 5. Therefore, 30 minus 25, then we divide this one by 9 and multiply by 5. Then we add 104.5. This becomes 107.28. Therefore, this one is now the upper quartile, which is called Q3. Now, for us to get what we call the semi-interquartile range, and for this matter, the quartile deviation, then we need to get Q3 minus Q1, and we divide by 2. Therefore, for us to arrive at the answer, we need to get 107.28 minus 98, then we divide by 2. Divide by 2. So this one is going to give us 4.639 to 4 significant figures. So this is the final answer. Thank you for following. Subscribe and share this link with your friends.